So, be it our mobile phone, be it our Google Maps, when we go out and driving, and various other applications, the television that we watch, internet that we are using, everything is connected to space technology. So we are like breathing space technology. I received a message from Dhwani. Yeah, it's going to be super exciting session. Thank you so much. Have your questions ready because these guys are like the best in their industry. And this topic is very interesting. And you might have read about the Tiwari space already, that what they are doing. They are building small satellites, and they are one of the first private space technology company in India. Though before then, there had been people whom I know as well. They had been trying to set up a business, but planning to set up a business, trying to set up a business is different than actually setting it up. So Dubai Space is one of the first to actually set up the business.
Good evening, Vishal sir.
Hi Chaitra, good evening. Hi Keshav. Thanks a lot.
Hi, good evening,
for having me here.
Thank you, sir. Thank you so much. So, Chaitra, if everyone is here, then should we start?
Yes, sir. Let's start.
Okay. Vishal sir, I can't see you.
Yeah, give me a few seconds. I will just get it sorted.
Sure.
Yeah, hi Keshav.
Hi, sir. I still can't see you for some reason.
Yeah, my video is on now. So.
Let me switch the view. Just yeah, now it is. Yeah. Oh, so you are working from office, so that's why I'm asking.
Yeah.
Great. So let's start. So good evening, everyone. Very warm welcome to everyone. And as we have already discussed that today's session is going to be super exciting because we'll be,
let's say if
Kshetra, can you please make sure that everybody is on mute? Yeah, so today's session is going to be absolutely exciting because it's about space talk, and when we talk about space technology, there are lots of fantasies involved, and it's also exciting to know that how reality matches with what we have watched in sci-fi movies or what we have watched in television like Nat Geo, Discovery, etc. So those days are gone where we used to just sit and fantasize. Now there are people actually in our country who are actually doing these stuffs. So good to have you, Vishal sir, and I'm sure this session is going to be absolutely amazing and full of knowledge and entertaining. I won't say entertaining, but yeah, full of science. Yeah, thank you, sir. So yeah, sir, I would let you describe your journey a bit and what are you currently doing and what is in the prospects of the space for a wider audience, just to be familiar.
Okay, Keshav, thank you. Thanks a lot for that. I think we can directly go towards the day's agenda in terms of discussing how it is, how what we're going to discuss about, and so on. In that prospect, we'll again be discussing about what we at Dhruva do as a company as well. So, with your firm permission, I would like to just share my screen and begin on the presentation. Is that all right?
Sure, sir. Sure, sir. Yes.
So, I hope my screen's visible. So, I'm just
Yes, sir.
gonna.
Yes, sir. It is. Yeah.
Wonderful. So, thanks everyone for being here on this call today. I think you all have been having a lovely time doing another Space Apps challenge along with someone. So, I think in that aspect, we all would like to, just see like what we are as a company. But other than that, what's in store for people wanting to do certain things in space, not just as engineers, but beyond that as well. But in that pursuit, I would like to just give a brief history on what we, as in, as a country, have been doing in the space side of things, although it starts as Dhruva Space and so on. So, I think I'll just directly jump into a quick snapshot on what has been done so far. So what you're seeing is what ISRO has been doing over the last 5 to 6 decades of its space research and exploration. So over the years, ISRO has sent over 60 or 70 satellites where they have developed right from simple communication satellites to far-reaching advanced Earth observation missions in terms of imaging in different bands and so on and so forth. So at the end of the day, all of this culminates in making life better on Earth. This has been the mandate for ISRO from day one. And in that aspect is how we also would like to work at Dhruva, where we want to enable space technology for betterment of life on Earth, using this technology to do better things on Earth. So keeping Dhruva aside, if you look at how far we have come forward right now, what you see on the, this is the class of launch vehicles that India has developed over the last 5, 6 decades, where we started with the SLV and now we have these behemoths in the name of PSLVs and GSLVs that we've been using for our multiple missions inside the country itself. Not just concentrating on low Earth missions in terms of Earth observation and communication. We have moved towards interplanetary missions, be it exploring Moon, Mars, and the other planets in the coming future as well. So this has been a very interesting work that's been happening on ISRO side of things or at the national space side of things in the country. So just understanding as to where we stand as a country, we can always look at our launch capabilities itself. So the current ones that are flying as such is the PSLV and GSLV, which is used for low Earth orbit and geostationary orbits and so on. In addition, there is a current development that's happening on the small satellite launch vehicle where things are moving towards much smaller, masses of satellites. Because when you talk about satellites, people think of anything the size of a small SUV. But what we're looking at is satellite technology moving towards building things size of a desktop printer. So to launch these kind of satellites, we need smaller launch vehicles, and ISRO is moving towards have developed small satellite launch vehicles, and we can expect launches of these launch vehicles in the coming months and so on. So this, the way this whole development has happened, like one thing we know possibly is that PSLV is the workhorse of the Indian Space Research Organization, wherein it has an impeccable track record with very minimal failures comparing it to the rest of the launch vehicles across the world. In fact, it's one of the most affordable launch vehicles across the world, where we are helping people have faster and easier access to space as we go by. Now, it's not just about rockets or it's not just about doing low Earth orbital missions. It's always a question of how far has Indian Space Research Organization come towards. The Indian spaceflight program, especially focused towards the human spaceflight program, started somewhere with collaboration with the former USSR. wherein you did see once Rakesh Sharma reach the stars and so on and so forth. But what we're looking at here is this is restarted almost like 10, 15 years ago. Continued research has been going on. We are looking at our own space station, our own astronauts moving towards having our own infrastructure out there in space built and completely trained in the country in the upcoming years. So the human spaceflight program was not a one-time activity, but it's going towards and expanding in the upcoming years, which is what we're looking at. So that's broadly on like the broader space side of things like this role. But where do we come in right now? Well, we started as a company, I guess one of the first satellite manufacturing company. We started in 2012. We were based out of Bangalore, but now we have moved to Hyderabad and we have expanded in terms of what we do as a company, and not just as satellites, but a bit beyond that. So we'll just deal with that coming slides. So what we're looking at is big satellites. When we talk about satellites above 1,000 kilos or just a little less than 1,000 kilos, where I mentioned satellites the size of SUVs and so on. But what we're looking at is building smaller satellites all the way up to 300 kilograms. These are extremely faster to make as compared to traditional satellites, which takes like 5 to 10 years of development, and they are extremely affordable to build. And as groups of these satellites, they're replacing single large satellites, which cost north of few hundred millions of dollars. Now, how we are looking at it is like when you put all of these satellites together, they have a much higher commercial potential. These are known as constellation satellites, and we are working towards providing this as a enabling people in setting up these small satellite constellations and making interesting outputs from it, interesting applications on ground. Now, as a company, what we do. So, what Tiwari does is we are a full stack space engineering solution. We work on the space, the launch, and the ground segment. On the space side of things, we manufacture satellites, but it's not just about the fabrication. It's about the design of the mission, the mission analysis and understanding of it, getting all the subsystems together, assembling, integrating them, qualifying and testing them, building a mission with multiple satellites, and then possibly the constellation communicating with itself as a network and communicating to the ground as a network. So as a complete solution, we work on the space segment side of things. On the launch segment side of things, we build what are known as the CubeSat deployers or small satellite deployers. So these are interfaces between the satellites and the launch vehicles, which help in injecting or putting satellites into orbit. These are advanced mechanics and electronic systems that we design and build throughout. Now, you have a satellite, you have a deployer which puts things into space. But once you go into space, you should be able to communicate, control, and operate your satellite itself. For that, we work on the ground segment where we do complete satellite controls and operations. We currently work on the VHF, UHF, S and X bands. We build them as remotely operable terminals where you don't need manpower right at the ground station. So basically, sitting at any part of the planet, you can access these ground stations and control your space asset, or in simpler terms, your satellites and your satellite constellations, and operate them, receive data from them, send data to them, interact with them, and provide solutions on the planet. So as a whole, this is where we are as a company, where we do a full stack space engineering solution, where we just want to put a small experiment in space, be it could be a physics experiment or drug development with respect to pharmaceuticals, or you name it with respect to what you want to do in the microgravity experiment. We enable you to achieve that objective using our space, launch, and ground segment, a completely integrated full stack space engineering solution. That is what we do as a company. So beyond this, but what is the rest of the Indian space sector doing? We have a whole new bunch of startups. What you see is a small snapshot of a few startups that are in the country, where they work in different segments. The launch segment, where they're looking at Skyroot, Agnical and Bellatrix, building their own launch vehicles, propulsion systems. And then you have Astrom Satellites, Astro and Pixel, where they're building their own satellites or their own satellite constellations. That's realizing success. And then you have companies like Astrogate and so on, ground terminals for better communication, satellite-based communication. So what you see is like these three large segments of these things coming together, bringing advanced technology, developing advanced technology just outside ISRO on the private sector side of things, and this is the new economy that as a company we are not necessarily looking the rest of the company, but work very closely with them. They are all friends of ours where we have complementing technologies and we we have very close working relationship with the references now, but we are basically, whoever you see on the screens are friends of the industry. That's basically a small snapshot of the technological side of the Indian space startup. In addition, you have the older companies or the old space companies, so to speak, be it Airbus, Lockheed Martin, and so on, having their apart from this, you do have a lot of companies that are looking at space education, awareness, and so on. So that's a whole different. Now, coming to the topic today, where what is possible on the space you graduates, be it engineers or non-engineers. I wanted to give you a round, complete analysis of how we are looking at it. So on the engineering side of things, very simply put, space is a heavily interdisciplinary or a multidisciplinary. So space is just the environment name part, and all or most of the engineering domains are applicable there. So be it whether you build the structures in the satellites, or the mechanisms in the launch vehicle system, or on the ground segment side of things, or mechanical, electronics, and electrical engineering, along with computer science on the base. In addition, when you have two devices that are apart from each other, you're going to be communication systems. When you're dealing with propulsion systems, you're talking with chemical systems. And once you have this large amount of communication data or imagery data coming into the picture, and you're dealing with different kinds of payloads, be it images and so on, you're looking at data sciences and what I'm talking about here is not limited to our space, but this is the broader scene of what is possible on the space sector, not just in terms of
Vishal sir, Vishal sir, sorry to interrupt. Your voice is breaking a bit. So yeah, we have received this query from lots of participants. So you may want to reset the connection or something.
audible now.
Maybe,
Is it better?
yeah, it is better. Yes, it is. Yeah.
Right, yeah.
Thank you, sir.
It's raining outside, so there's a lot of noise.
Yes, yes, yes.
So yeah, basically, considering the technologies that we build on the space side of things is interdisciplinary. You name it, basically, it's possible to implement any kind of engineering or any kind of engineering has an application that it finds on the space domain side of things. What's actually not mentioned here is biosciences. There's a good amount of biosciences research that happens in microgravity environment. So no domain is really restricted. Space is just a place you do engineering. So your creativity or imagination is your boundary for it. And as I mentioned, what is displayed here is not limited necessarily to the raw space, but it's just beyond as to what we do. But on the private or the commercial or the let's say the government sector side of things, these are applications. But that's purely on the engineering side of things. And as I understand, a major part of the crowd here are engineers or would-be engineers or engineers in training. But going away from that, when you look at business and marketing side of things, because of course, start as a engineer, you're not going to just stop there, but you probably would diversify based on your interests. So on the business and marketing side of things, we're always looking at the end of the day, a commercial business has multitudes of requirements. Be it on the strategy side of things, how do you commercialize a project in terms of going towards sales and marketing side of things? How do you run a company in terms of its infrastructure, in terms of its capacities, in terms of its manpower, and so on and so forth? That comes in operations. And at the end of the day, it's a brand that you're trying to build, and we're looking at digital marketing, graphic design. These are basically at the end of the day, even if you call it just space technology or a commercial space startup, you're going to have lots of requirements on these side of things as well. And finally, coming to a lot less spoken, but a very, very important part of space side of things is the regulatory and finance side of things. Considering it's a very nascent or upcoming domain in the country in terms of the private side of things, be it on the space policy or the regulatory side of things, understanding how space law and policy exists across the world, how we can adapt it to our own ecosystem, and how things are going to develop in terms of ease of doing business or getting the necessary clearances and so on. And in addition, considering the scale of the project, be it in terms of building a satellite or building a launch vehicle and doing launches, we're looking at what sort of insurances are we looking at. Is it a launch vehicle failure or is it a satellite failure in orbit? What sort of financial safeguards need to be figured out? And figuring it out with respect to having a company work sustainably is a very important aspect. So considering all of these things, so you see a wide motive requirement in this industry. There's always a understanding, when you look at it, hey, it is space, it's probably complex or bounded by walls that is not reachable. What I want to actually really communicate to all of you budding engineers and the rest of the crowd here is um, it is like any other domain where you have requirements over the board in terms of what you do. But it is unlike any other domain because of the kind of work that we do in terms of the more specific kind of engineering that we do, in terms of the more finest and rather uh, risk-oriented kind of approach that we take in terms of the technology. So that's probably what we do as a company and what you can look at as an expectation when you go out there on the commercial space startup side of things. Yeah, so that's probably a bunch of things that I want to put across today. Yeah. Thank you. What do you think?
So, yeah, so sir, thank you so much for giving the whole perspective behind it. And yeah, I'm sure that was the very useful information for young aspirants. Sir, I would like to ask that how is India is still accelerating at a desired pace in space race? The technological development that here happening and startups here are popping up, are they enough or still the regulations in India are prohibiting certain startups to experiment a bit when it comes to launching technology, especially because its ballistic missile is into place and you cannot test it because of hostile neighbor. So, are these things still holding us back, or we have a solution figured out already?
So there are two aspects to this question. One, in terms of all it a space phase and are we doing enough? So what we believe in, not just as a company, but as professionals on the space side of things, um, it's a domain that works together across across the globe. It's highly collaborative across the globe. Often it's not a race between companies or not a race between countries, rather trying to move towards a common goal in terms of exploring space for betterment on the ground. So that's one aspect of it, right? So in that sense, we don't see it as race. And considering if you want to compare it, we are doing pretty well in terms of the kind of technologies that we're bringing. Um, but being one of the early adopters on this side of the planet in terms of the space technology, where we were and where we have come is quite far. And the amount of um, the fundamental idea is technology is not just for the sake of doing it. One of the major aspects as a country that we wanted to do was make life better on the ground, right? So if you look at the earliest achievements, was not sending a satellite to space or not building a rocket. The first thing that was done was establishing a bunch of ground stations in the country. So this was done by Professor Keshav back then when ISRO was being set up, right? The whole idea was to set up these ground stations, take the union government's communication, the rest of the country. One of the first broadcasts that was done was Doordarshan. The whole point was that in terms of making things accessible to people on the ground, having better access to technology, better access to knowledge, making things better on ground. So in that sense, we have gone from doing Doordarshan to understanding better on predicting how weather works. If there are a bunch of people here who are from coastal cities, they would definitely understand how cyclone works every monsoon or just before monsoons and so on. When it hits, there's a lot of destruction. And what we see is better disaster management from a national all the way up to the ground level. There's been a huge change in terms of how we understand this data, how we mobilize things, and how we are doing disaster management. How we are handling the rest of the domains, be it with agriculture and oil and infrastructure and resource management, has drastically changed on what we do with these satellites. These are probably not immediately accurate, but a lot of these things have been enabled by the space technologies that ISRO has built over the last several years. And in addition, the kind of launch vehicles that we have built has made us a lot more sustainable in terms of how we support our own endeavors to make life better on Earth. So in that sense, it's not necessarily about a race, rather it's about doing what's best for the people in your own community or your country and so on. That's one aspect of the question. The second part in terms of are things prohibitive or enabling. Um, for an example, on a very very specific anecdote here would be, who has existed as a company over the last 8 years from 2012, 9 years now. We're going to be 9 years old in November. Um, we have existed, we have built our systems, we are a legal existing company. So there is no real restriction as such. You have launch with companies like Agnikul and Kairos, especially these people have been building their own system, testing their systems. We have been working very closely with the space research organizations over the last so many years in terms of building our system. So we don't see any restrictions as such. We don't see anything that's prohibitive as such. For all, I would say like it has always been enabling in terms of be it in providing technical support or be it in providing any other kind of support that we might possibly need to their investors. So that's where things are. What I'm looking forward to is now with the establishment of NSIL in space and so on, these collaborations are expected to grow stronger and possibly all of us growing together and doing better things right here. Yeah. Keshav, you're muted.
Sorry, sir. So, sir, you might have noticed that very early startups in the space sector in India, they gradually have either moved out to Singapore or they have moved out to Europe. So, what do you think could have been the reason, and how can we turn the tide, or you can say whether the tide has already turned around and now companies are choosing to stay here in India?
Yeah. So I'm not exactly sure which startups are you referring to, but we've been here for the last 9 years. The snapshot screen that I showed you, where I showed a sample of the many startups that are there in the country that are still based out of India. Uh, we did not really see a tide going away. At the end of the day, what each company does is a personal decision or a commercial decision, whatever they do. Um, it could be for a myriad of reasons which I am unable to comment on. Rather, what we are seeing is a lot of startups still working around here. The last year has been uh, rough, but very interesting, at least in terms of the startup ecosystem side of things. We've seen a bunch of startups raising their initial rounds of funding, landing projects, and progressing with their development. So I think we are at a good pace in that direction.
Yes, sir. So, sir, while you are developing a small satellite, who are your usual customers? Are these universities who are trying to do some experiments, or they are military people or telecom companies? Who are your usual customers?
So there's not going to be a specific answer for it because almost every domain that you mentioned are our customers. Because you will always find these technologies having multiple uses, be it on a academic side of things, they're looking at new technology demonstrations. Wherein it's not necessarily just a university wanting to build a small satellite, but wherein you want to put an experiment to space and then you build a satellite around it and so on. On the defense or the national security side of things, there are definitely requirements, which is a very standard thing in terms of how things go, for that matter. On the commercial side of things, like I mentioned, be it in terms of managing infrastructure, natural resources, or having better communication, there are always requirements on those side of things. What we are looking at is an increased requirement uh, on all of these aspects, be it on the communication or imaging side of things. The use cases are different, but there's definitely a interest and adoption of the space side of things and adoption of using space for doing things on Earth has increased, so to speak.
Yes, sir. So, sir, for the young aspirants who are still in the exploration stage, obviously there is one big side of thing where we all agree is is knowing the thing, like researching a bit, educating yourself. But there are other aspects also. So, commercial side you have already touched a bit, and when I talk about a few other aspects, like let's say ki, how what are the usual sources of raising the funding to get into space technology, and how profitable is the business? Is this really profitable, and if yes, then how we come into positive cash flow? What's the life cycle? How much time does it take?
Um, okay, so I'll address the second part of the question first in terms
Yes.
of profitability, sustainability, and then at the end of the day, be it space or any other sector, it's a business, and a business needs to look at uh, positive cash flows, like you mentioned, or rather, how I look at it is it needs to be a sustainable development in terms of how you do work, right? So, in that sense, how we work with things is we don't necessarily go for a product based business model. Rather, we look at having the technology, finding a client to build for it, and we build it around a client based. So we kind of work with a hybrid kind of an approach there, which kind of keeps us afloat while building these technologies and getting them into realization.
Chaitra, please.